So dear participants, in first couple of lectures on programmable logic controllers, we have got an idea about conventional relay circuits and how that problem can be overcome if we can employ a smart microprocessor or microcontroller based arrangement by which we are not needed to keep rewiring the circuit if the application demand is different. That we have seen. We have also seen that what are the basic postulates to automate certain industrial operation. We have seen the example of a drilling operation and how several switches are to be connected to it, how we can justify the position of the switches, and how we have to wire the system to various relays in order to see that the entire operation is automatic. That we have seen. At the last, we have taken the example of a modern washing machine in which we have seen that there are several switches at the input side, several sensors at the input side, and according to the situation of the input switches and sensors, the condition of several output actuators are affected. We have seen that, for example, in a washing machine, there is a water heater, there is a solenoid to open the water connection onto the drum of the washing machine. We have seen that motor is another actuator. We need to control the direction of motor rotation. We need to control the type of motor rotation. So all these things can be done by dint of the condition of the switches or the sensors on the input side. We have seen that if such a complex system, although washing machine is not a very complex machine, but still even under that circumstances, if we do not have an intelligent logic system in the circuit, then it will be very hard for us to maintain all the functions automatically, and therefore there are advent of intelligent devices. Now whenever a very small element like washing machine is considered, then PLC do not come into the figure. A very low cost controller or microcontroller, whatever you say, that can serve the purpose. But these programmable logic controllers are truly having unending capabilities, right from very short brick type units. Nowadays you have got gigantic modular PLCs with very high number of input output capability, communication capability, driving capability, and therefore we can say that whatever automation is right now happening in industries, PLCs play one of the major players in that. And with this much introduction, let us start with lecture 2. Initially, let us try to define the programmable logic controllers. You can see that this is a microprocessor based controller, and a PLC uses programmable memory to store instructions. That means you can program the memory. Whenever you are putting some new instructions, you are actually program the memory, and during the operation also the memory is continuously maneuvered by the process. And what the PLC actually do? Why do we need this microcontroller or microprocessor, or why need to program the memory? Because we want to implement functions. Whenever the functions are considered, we can see that a PLC can perform several operations. It can perform logic operation, sequencing operation, timing operation, counting operation, and arithmetic operation. And finally, the purpose of solving all these operations is to control machines and processes. So unlike our approach in several microprocessor or microcontroller courses where we try to achieve some sort of mathematical operation using the processors or controllers. In case of PLCs, the ultimate aim will be to control machines and processes. So how we can apply the sense of logic, the sense of sequencing, the sense of timing, counting and mathematical operations that we are to apply for control of external machines or processes. Otherwise there is no goodness of learning a PLC. You can see the block diagram of the PLC. It is very simply scripted. We are dependent on some inputs to get the outputs, and how the inputs decide the output, or the outputs are depending on the inputs, are decided by the program that we have fed in the central processing unit of the PLC. So let us now concile the definition. A PLC is a special form of microprocessor based controller using programmable memory to store instruction to implement the functions such as logic, sequencing, timing, counting and arithmetic functions in order to control machines and processes. If you see the historic aspects, then the first PLC was developed in 1969 and now they are widely used from small self-contained units which actually apply 20 digital inputs or outputs or less than that to modular systems that can be used for large number of input outputs. They can handle digital inputs outputs, analog input outputs, high speed counting, high speed pulse generation and carry out proportional integral derivative control modes. Now you see what I mean to say is that when the first PLC was invented in 1969, it was the basic necessity of getting processes automated, because PLCs are capable of doing the logic operations, and whenever you will be performing your experiments during your practical sessions, and you will also get into actual field to apply the PLCs, you will find that in many of the cases the demand is simply of digital input and digital output. That I must not say that they are very easy. Challenges are there also. The position of sensors, they play a very important role. The wiring of sensors, they play a very important role. Proper selection of sensors, they play a very important role. So all these things are there. But you might find that digital inputs and outputs, they play a major role in PLC programming. So from 1970 to today is 2020 or 2021. So we have crossed almost 50 years of using PLCs. Through all these years, there have been generations of changes in PLC. Nowadays, you can have PLCs which are very small and completely self-contained unit, where you have to only apply the external power to the PLC. Maybe they are having certain number of digital inputs and outputs. In very basic form, they do not have an analog input and output channel, because the demand for digital control is far more than the analog controls. So such type of PLCs are small PLCs. They can be said micro PLC. We will see in our next course of lecture, that are having digital inputs and outputs which are less than 20 or even less in number. However, when you require a heavy number of input and output channels to be controlled, then you have to go for bigger size PLCs, or you need to choose from the modular range of PLCs. In the modular systems, according to your requirement, you can have several adapts. जैसे कि हम जब पिज़्ज़ा खाने जाते हैं डोमिनोज में, तो देयर इज़ अ बेस्ट पिज़्ज़ा रहता है, उसके ऊपर देयर आर सर्टेन सॉर्ट ऑफ थिंग्स ऑलरेडी आपके पास रहता है। इसके बाद बोला जाता है टॉपिंग क्या चाहिए आपको। वैसे ही एड ऑन्स में यू कैन एड अप the modules according to your requirement. If you need more number of DIDO units, that means digital input digital output units, you can add that. You need more number of AIAO, that means analog input or analog output, you can add that. You need a thermocouple ready unit, that means a unit that will directly read from thermocouples, that is possible. You need a very high pulse train output for running a servo motor or a stepper motor, that is possible. And you know that there are the varieties, the mix-ups, they are so, I should say, having a great spectrum that it is not possible, to identify everything in one go. There may be PLCs which are having less number of input output, digital input outputs only, but they are capable of running a servo or a stepper motor with a very high speed pulse train output. There can be PLCs which are having say 3 inputs and 8 outputs, among which one of the input can be a high speed counter. So you cannot define actually whether the micro PLCs or the self-contained PLCs, brick PLCs, they will not have such facilities. So therefore, whenever you are to select a PLC, you need to be very cautious. You need to know about your application properly, and you need to talk to the experts of that company or the particular manufacturer from which you are trying to purchase the PLC. You should go to their data sheets properly. The data sheets, the brochures are the most important thing from which you can learn a lot about PLCs, Now see, where the PLCs are used, they are used in automation tasks for industrial processes in manufacturing. And this, again, this is manufacturing word is very wide, highly sprawled word, where we can have the operation of machining, we can have materials handling, we can have automated assembly, and we can have packaging. So all these things are giants in them. A machining operation can be of 1,000 types. Materials handling is a complete separate sector in manufacturing industry. Assembly is such a big thing that even assembly operations can make a 2-year degree program. And packaging also has right now become a complete separate sector in manufacturing industry. So all these things are giants in themselves, and therefore the PLCs have got plethora of different options to be installed in a particular operation. So in every case you need to know the proper demands of the situation, and accordingly you should select the PLC and you should program the PLC. For very simple automation tasks such as a household washing machine, PLCs are generally not used, where we are using low cost alternative like microcontrollers. However, when very demanding tasks are involved, where you have got tremendous computational necessities. Now you see, PLCs do not work with very high computational needs. They work basically on logics, and some mathematical functions have been embedded onto them so that they can perform basic type of mathematics. But if you need tremendous computational functions continuously happening, then PLCs are unable to serve such purpose. Then you need specially designed computers. For example, let me take the example of an aircraft flight control system, where in every second there are several condition changes. Several means maybe there are condition changes in 1,000 different aspects, and all these different aspects are very serious. They have to be taken care of with greatest precision, I should say greatest precision and tremendous calculative efforts. And therefore, under such circumstances, you cannot rely only on PLCs. So therefore, high-speed computational facility machines, especially specially designed computers, industrial computers are also there, which are actually applied in case of such operations. Now you see, whenever we are talking of programming a PLC, you can be very assured that computing languages and knowledge of computers is not that required. So if you have got a limited language knowledge of computers and computing languages, you can do program a PLC. Be sure that PLC is actually using a very simple and natural form of language. Whenever you go through couple of programs of the PLC, you will find that it is basically a sense of intuition that is required in programming a PLC. आपको इसके लिए पर्टिकुलर लैंग्वेज जानने की जरूरत नहीं पड़ेगी, जैसे कि सी लैंग्वेज हो, विजुअल बेसिक हो, ऐसे टाइप के लैंग्वेज है, जावा हो, ऐसे ओरेकल हो, ऐसे चीज आपको जानने की जरूरत नहीं है. What you need to know, you need to actually understand the situation. और कुछ नोटेशंस रहता है, ये जानना बहुत जरूरी है. वो नोटेशंस को ड्रॉ कैसे करना ये जानना जरूरी है. पर आपको लैंग्वेज, हायर लेवल लैंग्वेज जानने की जरूरत नहीं है. आपको कंप्यूटर नहीं आता है ना, कोई प्रॉब्लम नहीं. स्टिल यू कैन बी ए मास्टर इन प्रोग्रामिंग द PLCs. यू नीड टू अंडरस्टैंड द सिचुएशन प्रॉपर और इलेक्ट्रिकल सर्किट एंड फ्लो ऑफ करंट. ये चीज अगर आपको प्रॉपरली समझा, you can definitely master the language of programmable logic controllers. The basic thing that we are depending on is logic, because programming is chiefly concerned with implementation of logic and accordingly the switching operations at the output. So logic implementations take place at the CPU part. The switching operations is also taken place by the decisions taken by the CPU. But how the logic will be defined? The logic will be defined in accordance to the conditions of different input switches or sensors. The CPU will be deciding according to the logic which has been asked by the program that has been fed to the PLC, and finally it will be deciding the switching operations. The switching operations will be going to the output side, and accordingly the actuator will be under operation. So I will take an example. Suppose there are two switches A and B, and there is one actuator C. What conditions can arise? If both A and B, both of the switches, they are in on condition, then you put on C. Or if both are in on condition, you switch off another device D. Now you see, every time you will not find the switches, because whenever we are doing practicals or performing experiments with PLC, we are actually putting on some switch in order only to simulate a situation. We are actually simulating a situation. मतलब समझिए, आपके घर के दरवाजे पे आपने एक फोटो इलेक्ट्रिक सेंसर लगाया. जो सेंसर एक इंसान आएगा तो उसको सेंस करेगा, इंसान नहीं आएगा तो उसको सेंस नहीं कर पाएगा, नहीं करेगा डेफिनेटली. तो इंसान आया तो स्विच ऑन हो गया. अब ये स्विच कहां पे रहेगा? Whatever photoelectric sensors right now are available that are used for industrial purpose, they are having switches already installed inside. So either it will switch on or it will switch off, and accordingly the current will flow through one of the wires of the sensor. Now the point is, while performing experiment, it is not always possible to install such sensors for each and every unit of the PLC or input ports of the PLC, input terminals of the PLC. Under such circumstances, what we do, we simulate such situation with the help of switches. बहुत सारे जगह में बच्चों की यही प्रॉब्लम हो जाता है, समस्या खड़ी हो जाती है कि वो पीएलसी सीख तो लेते हैं, पीएलसी का प्रोग्राम भी थोड़ा फार आते रहता है, बट वही स्विच ऑन ऑफ करके। तो जब उनके सामने एक्चुअल परिस्थिति खड़ा की जाती है तो उस परिस्थिति को स्विच में कैसे तब्दील करना, ये दिमाग में नहीं आता है। सो दिस इज वेरी इंपॉर्टेंट वेयर यू शुड टेक केयर। Whenever we are talking of switch, it is actually a situation, and that situation we have to transform either in the language of putting off one switch or putting on one switch. This is the thing. Now you see input devices, what it can be. It can be sensors, it can be switches, and output devices, it can be motors, it can be valves. Now whenever I am talking of motors or valves, be sure that it may not be possible to connect the motors or the valves directly to PLC. The PLCs will be operating some sort of other device like a relay, like a contactor unit, like an I2P converter, and then you can connect such massive devices or massive actuators to the output terminals of the PLC. So these are the basic systems which you are connecting to the PLC. What the operator needs to do? The operator enters a sequence of instructions. This sequence of instructions is known as program into the memory of PLC. अब कंट्रोलर की काम क्या रहता है? कंट्रोलर की काम रहता है continuous monitoring of inputs according to the program, make necessary changes and reflect the changes at the output. सो ये बात आपको समझनी पड़ेगी। कंट्रोलर का मेन काम रहता है, पहले प्रोग्राम को देखो, प्रोग्राम के अनुसार इनपुट के कंडीशन को देखो, इनपुट के कंडीशन के अनुसार आउटपुट में क्या चेंज करना है वो डिसाइड करो, वो चेंज करो और वो चेंज आउटपुट पोर्ट्स में रिफ्लेक्ट करो। सो देयर आर सम इनपुट पोर्ट इन विच स्विचेस और सेंसर्स आर कनेक्टेड, इन द सीपीयू देयर इज द प्रोग्राम, and at the output there are several actuators that are connected. Now you see that the role of the controller is to continuously scan the input side, continuously scan the input terminals. According to the program, it then decides what are the condition of the input terminal. So according to the conditions of the input terminal and the logic which is expected, it will decide what will be the condition at the output terminals. So after it takes the decision, it changes the output terminals in that way. Changes the output terminal means that either it will make the output terminals from low to high or high to low, or it will retain the condition of the output terminal as it was before that particular scan. So this is the basic operation of a PLC. Definitely we will see it in more I should say elaborated manner in next part of lecture. I stop now and I will again continue with the next part of this lecture. Thank you.